Welcome back to the deep dive. Today we're looking at a piece of hardware that is basically the nervous system for next generation displays. It's the NTI DP8K-FO-70M-MMLC.
Which is quite a mouthful of a model number.
It really is. But let's just cut to what it is. We're talking about a 70-meter long cable that costs about $285. And the real hook here isn't just the length. It's the sheer engineering that goes into moving 8K video that far.
Right, because normally physics is your enemy. You know, with a standard copper cable, you go more than a few meters with that much data, and the signal just degrades into nothing.
And you'd need a repeater, one of those little boxes you have to plug into the wall.
Exactly, a booster. But this NTI spec sheet, it calls this an active optical cable, and the key part is that it needs no external power supply.
So how does that work? It's pulling power from the device itself.
It is. It's this really clever hybrid design.
Yep.
You've got copper wires inside for the low power stuff, like the initial handshake between devices. But the actual video data, the heavy lifting, that gets converted into light.
Ah, so it sips just enough voltage from the DisplayPort pin to fire tiny lasers down the fiber optic strands.
Precisely. It turns electrons into photons at one end and then back into electrons at the display, all self-contained.
And the amount of data it's moving with that light is, well, it maxes out the DisplayPort 1.4 standard. We're at 32.4 gigabits per second.
That is just a massive pipe. And that bandwidth is why it can handle uncompressed Ultra HD 8K video at a full 60 frames per second.
Which is critical for things like medical imaging, I imagine. You can't have compression artifacts when you're looking at an MRI.
Absolutely. Or high-end digital signage.
Right.
But it also has this other side to it. If you drop the resolution, the performance scales up like crazy.
Right. I saw that. At 4K, it supports 120 hertz.
And if you go down to 1080p, you're getting a wild 240 hertz refresh rate.
So it suddenly goes from being a professional cinema cable to a tool for like an ultra-competitive gaming setup that's in another room from the PC.
Yeah, you get that fluid motion over a distance where copper would introduce a ton of latency if it even worked at all.
Okay, so the product name calls this low cost. At $285, that feels a little strange to me.
Well, context is everything.
Yeah.
For your living room, yeah, that's expensive. But NTI is aiming this at industrial and commercial use.
I see.
Think about fitting out a broadcast station or an avionics system in an airplane. In that context, $285 for a cable that just works reliably is practically a rounding error.
And that industrial focus also explains why they went with fiber for another reason. It's not just about distance, it's about noise.
Exactly. A copper cable is basically a long antenna. It'll pick up all sorts of RFI and EMI radio and electromagnetic interference from nearby machines.
Which would ruin the picture.
But optical fiber, since it's just light in a glass tube, is completely immune to that. You could run this thing right next to a high-voltage power line, and the signal would be pristine.
Which is why the source lists those aerospace and medical applications. Failure is just not an option there.
Right. And it's built to survive, too. The operating temperature range is minus 40 to 158 degrees Fahrenheit. It's incredibly robust.
But there is one huge catch with this whole active system. A big gotcha.
Oh, yeah. It is strictly a one-way street. The cable is directional.
Because you have those little computer chips in the connectors themselves doing the conversion from electricity to light.
Right. One end is labeled source, and the other is labeled display. And you have to get it right. The transmitter is at the source end, the receiver is at the display end.
Wow. So if you run 70 meters of this through a wall and then realize you have it backwards...
It just won't work at all. The display end literally cannot send a signal. It can only receive. That would be a very, very painful mistake to fix.
A $285 lesson in reading the label first.
Definitely.
Yeah.
A lot more planning than your average HDMI cable.
You know, it really makes you think about where all this is headed. We tend to think of the copper wiring in our walls as this permanent infrastructure.
That's a great point.
But as 8K becomes the new standard and then 16K after that, the bandwidth we need is going to skyrocket. That copper is going to hit a hard physical limit.
It already is, in many ways.
So here's the thought I'm left with. Right now, this is a low-cost industrial cable. But how long until active optical fiber, like this isn't a niche product, but a standard requirement for our own homes, for our gaming setups and TVs?
We might be closer to that than we think. The era of copper for high-speed video is definitely running out of red.
Something to consider before you seal up that next wall. Thanks for joining us on this deep dive.